In this video, we're going to be using a graphing utility to check some solution sets, but these are going to be unusual solution sets. So let's go ahead and let's start by graphing our first equation. So x squared plus 2x plus 4. And just really quick, notice how it says greater than 0. So that means we're looking for where it's positive. Where is it positive? Or where is it above the x-axis? So let's go ahead and let's graph that. And we see that it doesn't even cross the x-axis. It stays up top, which means that for every value of x, it's going to be positive. So let's go ahead and we'll just sketch a picture of that really quick. And here our answer is going to be all real numbers. And since we're looking for intervals, the way that we might write all real numbers as an interval would be from negative infinity to positive infinity. Because again, we were looking to see if this is our x-axis, where are we above that? And the answer was everywhere. All right, so let's go ahead and let's look at our next example. So we're going to go ahead and we're going to plug in, let's see, let's clear that out, x squared plus 2x plus 4, nope, 1, let's change that, so plus 1. And before we graph, let's just take a look and see, it wanted it to be less than or equal to 0. Okay, less than or equal to 0. So here, we want to know, when is it negative or equal to 0? Now we'll hit graph. And here we're going to notice that it's really never below the x-axis, but it does touch the x-axis at the number -1, meaning at least will be equal to 0. So let's sketch that really quick for later. So we're going to come up and we're just going to touch right there. So again, if we're looking for where does it go below or touch the x-axis, there's only one place, and that place is right there at -1. So to write that as a set or as a solution, we would just write the set -1, meaning the interval only exists at -1. Let's take a look at another unique and unusual solution set. So here we're going to take a look at x squared plus 3x plus 5 is less than 0. So here we're looking for only negative, meaning that if this was my graph, I just care about what is below the x-axis. So let's go ahead and let's plug that in and see what that graph's like. So we have y equals x squared plus 3x plus 5, and we'll hit graph, and we see that we kind of have another floating graph. This doesn't even touch the x-axis. So let's go ahead and sketch that really quick. And so we call this, when that happens and it doesn't occur at all, we call this the empty set. Okay, the empty set. Because it's a set of numbers where there is nothing in there. And so here we have no solution, right? We have no solution. Let's try another unique solution. Here we have x squared minus 4x plus 4 is strictly greater than 0. So let's go ahead and let's plug that in and see what that looks like. Well, let's write down what we're looking for. So we're looking for positive only. Only positive, which means that if I was looking at my graph, and this is my x-axis, I would care about only things that were above the x-axis. All right, so let's go ahead and let's graph that. So we have x squared minus 4x plus 4. Yep, just making sure this time. And we're going to go ahead and hit graph, and we see that it is above the x-axis everywhere, except at one point it does touch it right here at 2. So if we sketch that, and see that right here it touches at the point 2. And so how we would write that interval is we would say, well, from negative infinity to the number 2, unioned, oops, that's the wrong kind of a u, unioned with the interval from 2 to positive infinity. And so by writing it this way, we're excluding the number 2 because we're using our open interval notation as opposed to what we would use if it was closed and it was included.